Okay friends, so now let's start the properties of asymptotic notations. The first property I am going to discuss is reflexive property. Okay, so the reflexive property is for some function fn, we can write this fn as theta of same fn. Okay, we all know the definition of theta, so try to prove this according to the definition of theta notation and big O notation and omega notation. Okay, and if you don't able to do this, so write me in the comment box. I'll try to solve your doubt. Okay, so the reflexive property is fn is equal to theta of fn, and we can write also big O of fn and also omega of fn. Okay, so this is called the reflexive property of the asymptotic notations. So try to solve these three using the definition part. Okay, this is so easy. I hope you can do it, unless I'm here to solve that. So now the symmetric property. Okay, symmetric property is if we have some fn that is equal to theta of some other function gn, okay, then we can write gn is equal to theta of fn. This is true only for the theta notation. We cannot say that big O and omega are symmetric, but theta notation is symmetric. So fn is equal to theta of gn. It implies that gn is equal to theta of fn. So similarly, if we have gn is equal to theta of fn, which means this part, if we have this part, we also can write fn is equal to theta of gn. Okay, got it? So using also the definition part, you can solve this symmetric property also. So try to do that. So now the transitive property. Okay, transitive property is, let's say we have some function fn that is theta of gn. Okay, and we have some other function hn such that gn is equal to, means this gn is equal to theta of hn. Okay, means let's say we have fn, gn and hn, and fn is equal to theta of gn and gn is equal to theta of hn. Then we can say fn equal to theta of hn. Okay, so I'm trying here to draw the graph for fn, gn and hn, then you will get it how you will get Fn is equal to theta of Hn. Okay, so for Fn equal to theta of Gn, let's say C1 into Gn is going like this and C2 Gn is going like this. Okay, this is C1 into Gn, this is C2 into Gn. Okay, so Fn is going between this. So now Gn comes in this range. Okay, so now when Gn is equal to theta of Hn, so the Hn will come here, C1 into Hn will come here, down the C1 into Gn, means the area of G1 is between these two lines. Okay, so now C1 into Hn will be here and C2 into Hn will be something like here. Okay, because our Gn has to be between C1 into Hn and C1 into C2 into Hn. Okay, so clearly you can see the Fn, this line is between C2 into Hn and C1 into Hn. Okay, this Fn is coming between this area that is surrounded by the functions of the two functions of Hn. Okay, so due to the definition, okay, if C1 into Hn is less than equal to Fn and that is less than equal to C2 into Hn, so what we can say, Fn is equal to theta of Hn. Did you get it? So now similarly we can write the transitive property for Bigot notation like this. Fn, if Fn is equal to Bigot of Gn and Gn is equal to Bigot of Hn, then I can write here Fn is equal to Bigot of Hn. Okay, so same rule applies for omega notation also. Here if Fn is equal to omega of Gn and Gn is equal to omega of Hn, then we can write here Fn is equal to omega of Hn. Okay, so this same rule for transitivity is also applies for small o notation and small omega notation. Okay.